Staircase, but it's not just any staircase, it's Fibonacci staircase. And we're going to figure out how many ways is there for this guy to climb Fibonacci staircase. He can take one step at a time or two steps. And the question is, how many ways is there for him to go up n steps? He can do one step or two and then one, or any combination of that. That seems like a very difficult combinatorics problem, but in fact it's not. And we're going to use recursion to solve the problem. Now, I know what you're thinking. You're already starting to panic. You're thinking, I don't understand recursion. It's a mystery. It's a mystery. Yeah, it is in a way, but it's because, you know, people use strange, panic-inducing analogies, like it's a forest within a tree, or you know, something even more scary. It is a mirror looking into a mirror, or a function that calls itself, and blah blah blah. Okay, these things make students panic. Don't think about this. Okay, I'll show you a better analogy for recursion, and this is an analogy I'm gonna return to over and over again. Recursion, and I believe that this is the right way to understand it. Okay, it's laws of mechanics, or, you know, dynamical systems, laws of nature, law of mechanics. It's the same thing. If you're studying the orbit of a planet around the sun, you need initial conditions, okay, and you need differential equation. All right, that's what you need. Sometimes you need many differential equations, and then you have your system of nature, your dynamical system, and you can solve it. Laws of physics. Recursion is the same thing. You have initial conditions, and then you have recursion formula, recursion equation. We don't have a differential equation, we have a recursion equation, but it plays the same role. This is going to be our analogy. I'm going to return to this over and over again. If you keep this in mind, you're not going to panic, you're not going to go mad thinking about strange things like this. Okay? You can save your mind for worrying about the fourth dimension and other such things. All right, now, you'll see now how easy it is to do by recursion. Let's draw Fibonacci's staircase, and let's call this Gn is the number of ways to climb it. And it's got n steps. Okay, G is going to be the number of ways to climb this thing. All right, let's draw another one. Let's now pretend that we have taken one step. Remember, we have taken one step. So let's draw. How many steps are left here? Well, n minus one step. So how many ways to count this, or how many ways to go up these stairs? Well, it's got to be Gn minus 1. Remember, we say G is the number of ways to go up the stairs, right? G is the number of ways to go up the stairs. So here I have n minus 1 stairs, so there you go, Gn minus 1. I took one step already. Now, do the same thing. We're going to take two steps. Okay, how many steps are left? N minus 2. So, how many ways to climb n minus 2 steps? Ha! Crazy looking steps. Okay, how many ways to climb these n minus 2 steps? Well, you guessed right, Gn minus 2. Now, it's obvious that G of n equals Gn minus 1 plus Gn minus 2. And there you go. This is our differential equation. This is the analogy of the law of physics, or law of nature. And now we just need the initial conditions. Okay, so let's begin with a very simple case, one step. How many ways to count this? Now, how many ways to go up that step? He can do one step or two steps. He cannot do two steps here. There's only one way to climb this, by doing one step, so one way. In other words, g of 1 is 1. Now, 2 steps. Well, there's several ways to do this. I can climb 1 step and then 1 step, that's one way. Or I can do it in one shot with 2 steps, that's another way. So the number of ways to do this, g of 2 must be 2. Okay, so now I have a way of beginning the machine. I begin kind of like I have the sun and the earth. I start here at this initial condition and okay, the whole process starts and then it goes around and around and around. Well, that's what I'm going to do now. I start at these initial condition and I find the next one. So this is like g n minus 1 and this g n minus 2. I go back 1 step, back 2 steps. Okay, I have to add them together to get the present step. This is yesterday, before yesterday, and I get today if I add them together. Yesterday, before yesterday, I add them together and I get today. That's 3, and I can keep going now. 5, 8, 13. I'm sure you've seen these numbers before. They look like Fibonacci numbers. Well, they are, but it's a little bit different because Fibonacci sequence begins like this. 1, 1, 2, 3, and so on and so on and so on. It's a little bit off, you see, but the numbers are the same. Fibonacci number. Now, one of the great things about having differential equation or recursion equation like this, okay, one of the great things about this is that it immediately leads to computer program. And that's what we're going to do next time. We're going to write computer programs based on this idea, and you'll see how easy it is to solve other types of problem like this. Maybe you want to take 3 steps, how many ways to do that, and so on and so on. And you'll see, once you know this, then you know everything. You can write computer programs that churn out the answers. It's really amazing. This is a powerful thing. Recursion, no need to be scared of it, because it leads to correct computer programs, as we will see.